Hi, Cyprien here. In the previous video, I have shown to you how to transform this multi-layer piezoelectric transducer model into a parametric type of model where the PZT size can change and where you can launch on the cloud a series of simulation at the same time. And then I showed to you how to use the GUI to post-process each of those. Because when you calculate, I don't know, 100 simulations at the same time, for example, it's difficult to go one by one inside the GUI. So in this video tutorial now, I will show you how to go on the code side, how to, let's say, batch process all those results using an analyst mode review script. So let's go for it. So now I'm in the designer mode, so I have to open a new OnScale window first in the analyst mode. So let's go for the analyst. And when you start, there is nothing in it. So the first thing you have to do is to save your model, and you have to choose the extension review input or revimp, like that. So give it a name. So the name doesn't matter. Process results, for example. Save. And as soon as you save it, it seems like nothing changed, but actually it changed. The button here, for example, became activated, and now it's run review. So this, even if you have only the cloud available, review will be available to you locally on your computer. So you can run scripts, post-processing scripts, even if you do not have a local license. So let's start with how you can visualize your results. Plot a graph, for example, inside review. So the first instruction that you can add is read, and then F1 will be the name of one file. So I'm just creating a file called F1, and I will put inside the results that I want to read. And this result is inside this. So the only thing I have to do is to basically copy the name of this folder into this. So let's do that. Okay, so let's copy the path here to my folder, like that. And don't forget the name of the model. So the result I want to get is the FLX the history. So add a slash like that, add the name of your file. And now what review will do is that it will read this file and put the result of that file into the F1 file. Now the second instruction is I want to do a graph. So there is a command called graph, and then I will plot the first curve, which is saved into this file. And the instruction is, the last instruction will be term. So the term instruction will be basically pausing the script so that my plotting window will appear. Let's try it. Okay, so now I'm looking at the first curve inside this. At the same time, let's go into the post processor and let's have a look in the post processor at that. So you see that in my FLX HST history result, I have 1, 2, 3, 4, 5, 6 curves. So now I'm visualizing the first curve, which is this one. The second curve would be, sorry, I have to reset. Second curve will be the input voltage, the drive function. The fourth one is the charge at the top electrode, and then you have the voltage and the charge at the bottom electrodes. So if I wanted to display what is the charge at the top electrode is within review, the only thing I have to do is to change the 1 and 3 like that. And then I would be able to view this. So this is the voltage, right? Now there are several other options. So for example, if I want to plot two curves together, there is an instruction nView, which takes, for example, arguments like that, 2, 1. So I'll show you after what it means. And if I, like that, I plot first the first curve and then the second curve, I run that in review, I'll get both curves plotted at the same time. If I want to comment an instruction, I use the C command, and I can also draw the two curves on one line. And in this case, the curves will be drawn together. So now I'm only seeing one curve because the other one is so small that you cannot see it at the same time. So basically, it's not very useful. Now, how do I know what is this nView means? If you want to know about that, right-click, and there is Show Help for the function. And you see that at the bottom here, you have the different options for this. So now I showed you this nView 2 type 1 will show you this one. If you want a 4 type 1 will get that, and depending on what you want to print out, just use the nView with this. So now I'm looking at the new type of visualization. Now, if I want to see the old type, the one which was available before, if maybe you are a PZFlex user, you can use type standard. If you do that, you'll get the old way to visualize the curves. So it's more, it's older. Sometimes some functions are available in the old type and not in the new one, or vice versa. So depending on what you want, you'll have to check that. Okay, so now I just show you how to basically draw curves in review. So what I want is to show you how to automate and to batch process the results. So the first thing to do is to know how can I calculate impedance. So let's see how to calculate the impedance in review. And for that, head up to OnScale support. So it's support.onscale.com. And what you can do is that you go in the search field if you are on the main page and you search for review or maybe calculate impedance, and you will find this page. So, and there are a lot of documentation on review, so I advise you to read this page, what is review, to have more complete understanding of how it works, and you can read it in details. Now here I want to show you how to calculate the impedance. So I'm going to this page, calculate the impedance, and there is a formula. So if you go down, it's calculation. So here this command frec will basically take the time data from which are saved in my flex history file, and it will calculate based on that calculate the frequency domain. So it will do some use some Fourier fast transformation to calculate my impedance. So I'll just take that. So I just take that and I paste it basically into my review file. And now I need to do a graph of this. So let's go to plotting, copy the graph, and let's paste it afterwards. So I don't need that anymore, so I'll just remove this part. And let's see what it does. So what this function does is that this command will calculate the frequency from my time domain. So it will save the result in a local file called f2. This instruction type emp, it means that my result that I will obtain will be formulated in terms of amplitude and phase because those are complex numbers. So another alternative will be real imaginary type. And the input to this command is this function impedance, and my file f1 that I just created here, I have to give it two curves. One as the voltage, so if you remember, it's the third curve, and the other one will be the charge. So this is the fourth curve. So I'm feeding it the voltage and the charge curves at the top of the electrode, and it will use those time data to calculate the FFT and the frequency curve. So frequency curve, which is the impedance, right? And this function here, graph, is the same that I showed you before. So it has the n view to split into two views. And it has also a new function called pset window from 0 to 10 power 6. So this basically set up the scale of frequency that I want to draw. So it limits the window of my drawing. And I want to plot the first curve, which is located in this file here, which will be the amplitude of my impedance. And then the second one will be the phase of my impedance. So let's see what this script actually does. So if I run that in review, you see that I'm getting something like that. So why do I get this strange oscillation after? Those are very high frequencies that actually, so those results actually are false. So generally I don't look at those results, which means that my window is too large. So here in this case, I have just to decrease the window to 1 million hertz, so 1 gigahertz, right? Or maybe is it 2 gigahertz, right? Yeah, let's do that. Let's see again. Let's try again. And now it's much better. So, and the area which I want actually is this one. So I think I should limit at maybe, let's try it out. Maybe like that. And let's just use the new type of, I prefer the new way. Okay, I get now the amplitude of the impedance and the phase. Now that I got that for my first my first result, I could simply change the number to see the second one. This would be the second calculated result. This would be the third calculated result, etc. Now, of course, there are better ways, and one of the ways is to create a loop, because the language which is used in review to write all that is called symbol, and there are some ways to write the code so that you can use normal scripting type of loops, if functions, and all that. And if you're interested to know more about this, just go to the help. For example, go to the, I think you need to put it small like that. Yeah. Go to the, here, symbol commands, right? And here you'll have some ways to write do statements, go to if, and various kind of functions and stuff that you can do. So I'll show you some of those. And the basic syntax to write a loop is the following. Here you give a name to your loop. So it could be loop 1, for example. You state a variable I, and the loops start at 1 and finish at 100, and then you put a lot of stuff inside, and your loop will end up like that. And $, and then the name of the loop to close the loop like this. So I'll use this way right now. to show you how to put all that in a loop. So let's just do that right now. So give a name, loop1, give parameter, let's use capital I, and I have 9 files, so from 1 to 9, and at the end I'll put an and $sign, don't forget the $sign, loop1, like this. So now the only thing I need to do is to change the value here. So it would be nice if it was as simple as just put a $sign here and I to put it in variable. It's slightly more tricky than that because this language is not able to recognize the value of this within a string. So what you have to do is to change that into a variable and to change that in another variable. So let's call that inputs. So the first one, so the name of this variable will be a text type of variable. So text t file equal, and this will be the name of the file here. This, I'll just delete that for a moment. I put it here again. And instead, I'll put a $, and the name of the file. And I have to do it a second time. Text and tdir equal, and the name of the directory. And here, put it $tdir. Yes. So if I do that, I should be able to run that to run that in the loop. And let's try. I hope it works. So if you have some problems, everything will be listed here. So in this case, I have a small problem. Okay, it doesn't recognize this, so let me think. What could be the problem? I think I have to create another variable, text. Let's call it tpath equal this, and instead let's put the variable here like that. Let's see if that works. I hope it does. Still not working. Okay, I know I did a stupid mistake. The bar shouldn't be this direction, it should be bars like this. Okay, difficult to spot, but you know, this makes all the difference. So now if I run review, this is the first result, and like that I'm able to iterate through the different types of results. So now I'm seeing the same thing. So now if you see, I iterate, but the curve doesn't change. That's because you need to do a small modification here of the code. By default, the first time you import the function f2, if you try to re-import with the same name, it doesn't update. So you have to add an instruction called clear, C-L-E-R. There's no A, so only 4 letters, clear, like that. And if I try right now, you see that now I'm seeing the change. So I'm able to view the 9 type of results that I should be able to view since the beginning. Now let's try to do something else. Let's try to output a message here in the console telling me basically at which curve I'm visualizing right now. So to do that, there is a special command called simp. So simp is the name to define variables usually, but I will add this MSG like message and 1. 1 means one line. So the line that I'm writing after will be printed in the console. So if I say, for example, processing the file $i, so the file I'm processing right now, of 9, and let's see what this addition do. So now you see I'm visualizing the first curve, and here it's written processing file 1 of 9. And if I continue, it just tells me, okay, now I'm looking at file 2 of 9, 3 of 9, 4 of 9, etc. until the last file. And now comes the tricky part of today's video, the one that will take a bit more time. So I'll accelerate the most boring part. What if I want to know at each iteration what is the variable that I'm looking at? Because right now we don't really know. If you remember, I chose a certain variables, but I'd like to see that right now and maybe print it on the curve, print it on a file. So this is kind of basic stuff I want to do. And here the only way to do that is to recalculate. So let me do that right now. So I'll add a few variables first, and then I'll explain to you what it means. Okay, so what I just did, oh, and I have to change the value here. Okay, so what I just did is that I basically recalculated the range of calculation that I used. So I calculated the PZT thickness going from this value to this value. So this is why this is the beginning, this is the end. And I did 3 simulations. So if I calculate the step of PZT thickness in between each of those, I'm using this formula to do that. And the first value will be this. So this is initialization of this. Doing the same for the hard epoxy thickness. And now I have 2 variables that will, at each step of the loop, I can increment them in order to give me what is the current value of those 2 variables. So to do that, I have to slightly modify the loop as well. So right now I have a unique loop which goes from 1 to 9, and I have to actually do a double loop. I have to make a loop of 1 to 3 nested within another loop of 1 to 3 in order to recreate this. So I'll change in this to J. I'll call it the loop J here. And this will go from 1 to 3. And I'll put another loop in between. This will be the loop K, like that. And here's another nested loop. And I still want to keep this I. So what I'll do is that I will add another variable, symbol I, which will be equal to 0 here. And when I go into the loop, this variable will be equal to I plus 1. So at each step, it will be incremented. So I'm getting the full value of the loop. And now that I have those 2 values, J and K, I can use that to calculate the value of this at each step of the loop. So my current value of PZT at each step of the loop will be equal to this value plus the value of the loop, J, multiply by make sure you have a space in between this number. In case you miss a space or something like that, it doesn't work. So this is important to leave a space even in between the parentheses. Okay, so and multiply by the step. So this one, hard thick step. I don't need the parentheses here. Oh no, PZT, right? PZT step. So this will be the current value of PZT. And so same thing for hard. This time it's K, like that. And I will display in a message in the window using the same way here, the value of those two. So the value of PZT thickness, so let's say PZT THK will be equal to, so don't forget the $sign, like that. And I think I can do like that. I put 2 lines. If I put 2 lines, I should be able to write with 2 lines, I think. Let's try. Equal. I told you this is the tricky part. It takes a bit more time. Okay, and now there's still. Oh yeah. So this part here, actually, the incrementation should be done at the end. Otherwise, I will display the value of the message after I already incremented, so it will be a bit strange. So I'll just cut that and put it right after I draw the curves. And now let's try if it works. Run. So now I'm getting the 2 curves. I'm getting the value of the PZT thickness and the hard thickness. And you see that those value updates. And now I know exactly which value goes with each curve. So there are some ways to change the title of the curve. So you can put that on the title, you can print that, etc. Just go into the documentation and you'll know which kind of how to do this. Okay, so now I almost finished with this. There's one more thing which is actually very important, is how do I, let's say, extract the maximum frequency, the maximum of this impedance curve, and the frequency at which this maximum happens, and how do I save all of that in a file. This is the last part of this tutorial, which is really useful. And at the end, what I'll do is that I'll use a special function, again, simp at get. And this is a syntax that is worth remembering. So when you get, you do like that, for example, var, and then there is a function like this, and there is something like that. So what it does is that it will compute something here, and it will associate it and put it inside a variable. So that's how it works in this language. So here I will put fp and zp, and I will use a function called curve max, which will actually calculate what I want. And I will feed it with the f2 1, so the impedance curve. And I will also give him this window boundary. So if you want to know how this function works, just go into the help, simget, and you'll have all the details here. Okay, so now I'm calculating those, and I will save those on those 2 variables, fp and zp. And now my last step is to save all that into a CSV file. Very important, right? So to save all that in a CSV, this command is again simp message msg. Same that if I want to print to the console, but instead of printing to the console, what I'll do and you see it's actually written here. If you follow that file name, you can put it into a file. So the two these two symbols means adding at the end. So and here you can write a name of a CSV file. So I'll call it KPI report, for example, .csv. And each line that you put here will be printed into CSV format. So the first will be the I in this. I'll put a comma, and then I'll put my value of my PZT current and the value of my hard current. And then I'll put finally the value of my frequency of resonance and the value of the maximum of the curve. Okay, now let's see if it works. If it works, I should see something appearing not here, but here in this folder. Run review. So each step, the result will be added to a CSV, and you see that now I have this CSV which is here. So let's open external test file in Excel, and you see that I have my result in Excel format, which is wonderful. So it might seem a bit difficult to go over all those things in one video like that, which is short. So I advise you to try slowly all those things. I will give you the script so you can have a look. You can try by yourself this function and to reproduce this. And you can go also look at the help, read what we have in the documentation on the website. I know this takes a lot of time to understand how this works, but the good point is that once this script is written, you basically have nothing more to do. You don't have to click on 100 buttons every time you do a simulation to look at the result. You just post-process, you get your picture, you get exactly the results you need immediately. So it's a bit more work at the beginning, but once you understand how it works, it goes pretty fast afterwards. Okay, so I hope this video was useful for you, because it was not a video easy to make. Took me a lot of time. So I hope you enjoyed it and that it was useful. And if it was, please give it a like and please leave some comments and let me know what you think. Thank you very much for watching.